we are just connecting, we are just SSHing to the Raspberry Pi to
What is
look.
SSH?
We are trying to have a secure connection to the Raspberry Pi. No route to port 22. Why is that? Did it connect to the Netgear? Oh, I think so then. Let us change this. Why? Yes. Okay.
Okay, so what you have done is to connect the Raspberry Pi
Mm-hmm.
to the router. To-
For connecting Raspberry Pi to the router,
So now, what is the hardware configuration right now? The Raspberry Pi is connected to what?
an occupancy sensor right now,
Uh-huh.
and it has a Wi-Fi USB Wi-Fi dongle with it attached, so that it can connect to the any of the routers inside the internal network
So right now that you were having these mistakes was because it was connected to
to the another router. I was suspecting that it was connected to a different router, but no, it was connected to Netgear router.
the linear router.
Okay,
Okay.
okay. So yes, so after this, Pi asks you the password, which is a lot secretive. So after that, we are into Raspberry Pi. So here, what uh, the code for the Raspberry Pi is, we just created a very simple server, which is our socket server, and this is the code for it.
Do we have that code on online in
Yes,
GitHub?
yes.
Where in
No,
the
I mean not online in the sense. You can find this code for UDP handler anywhere in the Python package library itself. In any socket programming tutorials, most of the socket programming tutorials give you how to make your own server and how to make your own client to communicate with it.
So actually, this is the first step to make the Raspberry to have a socket, to be a socket server.
Yes.
Right?
Yes.
Can you explain us the code? What is it?
Yes. So what we here do is, first of all, this starts from the main where we set the IP address. So since the our Raspberry Pi changed the IP address to 1.0, we'll have to change it to 1.1.0 right now.
Mm-hmm.
And we also define the port on which port we are listening for requests.
Mm-hmm.
So generally 1 to 1000 are 1 to 100 are reserved for different protocols. So it is all obviously recommended to use something which is larger than 9000. After that, we're just creating through the socket library, because we are importing the socket library over here.
Mm-hmm.
And it's a Python standard library, so we don't need to
It's on
worry.
Python. Okay.
Yes, download it. We don't need to worry about its download. So we are just creating a UDP server over here with the host name and port, which we set already, and then we are giving an instance of our UDP handler class. The UDP handler class, which we have defined right now here, uh, takes even the data, and then it for our testing purposes, we have printed whatever address, whichever request we have gotten from different clients. After that, the use of GPIO comes in between, because we are actually listening to a GPIO interface on the Raspberry Pi.
Mm-hmm.
So we will be setting GPIO with it. So we are just setting the GPIO basic variables over here, and then we are setting the sensor, which pin the sensor, GPIO sensor is transmitting data to the occupancy sensor. So that's what we are doing here.
Mm-hmm. So this number, the number 4, is the pin where
Yes,
the
it's the
occupancy
pin.
sensor is
Yeah, that is
connected
the
to
pin
the.
number 4 of the Raspberry Pi,
Mm-hmm.
and this is the sensor number 4 which we are listening to right now
Mm-hmm.
from the general input-output interface of Raspberry Pi. So after setting up all the GPIO variables, we are just saying that if our data which we have got from different client is in the valid request, and right now uh, our valid request is only one, which is motion detect. We can scale it to different requests where we can access different informations, but for now, for basic purposes, we have only kept it that did we detect any motion.
Mm-hmm.
So if the data is, if the request contains this thing, then only we will be going into the GPIO sensor and trying to find out that whether the motion was detected or not.
Uh, so here, when you have this definition of is valid request is motion detect, what it means? What do you put a name, or what it means the valid request?
So valid request means that if there was any other data than is motion detect, the server would not be responding.
So where do you define that is motion detect? Where do you define that as a value?
As a value, as in okay, so this is the server defines that what should I respond to.
Ah.
Okay, what should I respond to?
Mm-hmm.
Server does not respond to all the requests because server has some definitions that this only this request in such a format will be replied to.
Mm-hmm.
Okay, so this, because we had the privilege of using our own server, that's why we created our own requests and our own point name. You will see that this valid request we will use in the end as as a point name for volttron for our GPIO interface, which we will be creating afterwards.
Okay.
Okay, so right, so as I said that then if we detect the motion, then we return true, or if we don't return detect motion, we return false. Otherwise, if the request in itself is not valid, then we return or respond data as 3, which is a bad request.
Mm-hmm.
That the client who has sent a bad request and it should not be entertained further by the server. So this is a very simple code for a server.
Yeah.
When you just run this code, the server responds nothing. Only if when a client actually requests something, that the server tries to log into the console output stream, that this client made this request.
Mm-hmm.
Nothing more than that. And for our purposes, for the occupancy sensor, this is more than sufficient to get information out of it, because
One question, because in the code of the of GPO,
Mhm.
uh, you define when you write a Python code importing the GPO code, you define what is motion detected and what is no motion, right? So here, how do you find the response data 1 and 2?
We did not find it. It's more about what response. So this is just like a vocabulary. I mean, you can define it whatever you want as response data 1 and response data 2. The point is that the person who is grabbing this response should be able to make meaning out of it.
No, yes, yes, but when you write from the occupancy sensor, when you write a code for the occupancy sensor for the
Mm-hmm.
Raspberry Pi, importing the GPO, you set a code that it says if there's a difference of time between one and the other, you will write motion detected, or if not, no motion. So where have you defined that answer? That's my question. According to how the sensor
So
is working.
I have not defined any time difference in.
So
There is no time difference right now.
because you already are importing the RPI GPO,
Yes.
and there is already defined, this answer is already defined there.
No, the GPIO only gives you true and false.
Yes,
Whether the
exactly. Uh-huh.
these things only
But the
give.
RPI dot GPO
Yes.
GPIO.
Yeah, they only say you whether the motion is there or not, true or
Mm-hmm.
false. Other than that, there is nothing more which GPIO tells us about the occupancy sensor, and that is the only information which we intend to take it out from it
Mm-hmm.
right now.
Okay.
And true and false, because we want the variables which the client gets directly as boolean, so we can cast it directly to some of the primitive types inside Python.
Okay.
That's why we are returning true or false.
Okay.
And that was basically the decision when we
Mm-hmm.
took.
So that was a soccer. So
Yeah.
how do you activate that one? So now that you have changed the IP address, how do you activate it?
You just run the Python file, and it is running right now with no errors. This will show you some of the clients connecting to it when your volttron code from the driver side, client side, will be requesting something to it.
Mm-hmm.
So it might request something as bad request, even it might request something as valid request. But since we have enabled logging into the server, we'll be able to at least see what was requested and
Mm-hmm.
by whom.
Oh, okay.
Okay.
So now, what should be the output right now? Are we waiting for something right now?
No, we are not waiting. It's still running, and we can actually just try to. So the GPIO client .py was just made just to see whether you know our socket server is running and we are able to ping to our
Mm-hmm.
server. So what we can do is we can directly go into volttron and directly try to ping to the server just to check whether our server is running or not.
Mm-hmm.
It was in the interfaces. Yes.
I think you have to change the address. Right?
Yeah, basically I think I might have to change the address. So yes, it is 1.10.
So this is the interface for the socket.
No, this is just a right now. It's just a client file of. It's an independent Python file, which I wrote just to see whether my socket server is running as expected. It's not erroring out. Just to see that there is no firewall between these two
Mm-hmm.
servers, which is blocking my request.
Okay.
Right. This is easier because before you are building the interface, you need to know that things are connecting,
Mm-hmm.
that there is no mishap in communication. So when you just try to do this, it sends request and says it received false.
Can you go and move it?
The occupancy sensor.
Okay. Good.
It received true.
Yeah, I received true.
Okay, but the interesting thing to see is that this server will say what actually was given.
Oh, I.
And in the Raspberry Pi, this is all like this is the server in the Raspberry Pi.
Sorry, I missed what the step before to be able to see this. What did you do? Do you run you just run the
It is just sending the request whether motion is detected or not, and then it is telling us what it received. It received false because there is no one right now besides the occupancy sensor, and it will say true when it resigns. So just checking whether two independent
interface? Okay.
machines can communicate in the network.
Mm-hmm.
This will help you in solving whether there are whether there is any kind of firewall issues between those two things.
Mm-hmm.
Like for me, when I was trying to build it the first time, I had to first clear off the firewall's rules through IP tables.
Mm-hmm.
So you can try it and do that, as sometimes in some of the OSs it just happens rapidly, but for me it took a little bit of time just to understand what IP tables is and how you can manipulate so that my requests are received by the server.
So, what is the next step then? Because you showed us that code
Yes. So
right there.
this code is just for this, and mostly what part you will be taking from this uh, is this part where you're setting up your socket client,
Mm-hmm.
and it's a dgram client. That means it's a UDP client,
Mm-hmm.
and then you are sending a request and receiving it.
Mm-hmm.
This is the part of the code which we will be taking it to your GPIO interface.
Mm-hmm. So now in the now I think the next step is the agent or the driver, right?
Yes.
Mm-hmm.
So, the next step is first to see whether you're able to communicate with the master driver, and master driver is able to then directly um, so is able to directly you know able to communicate as well as log information from whatever interface we have built
Yeah.
up.
So these are all the files that we commit
Changed.
in our own
No,
repository.
these are the files which are changed and which are not committed right now. I was just trying to see whether there was any change in
No, but
GP.
these ones.
Yes, so I was just trying to see whether there is any difference in GPIO which I committed. So this is changes in the device address. This is in the driver config files. Okay. Um. Yes, this is GPIO, right? Okay. All right. I changed something in GPIO. Okay. So it is better that I add GPIO and commit it. Changes for scrape all. And after committing, I push it to a branch. Invalid username. Okay, it's password. Permission to volttron origin.
Going to pause.
Okay.